Early on, we decided that if we were going to build a real airline simulation, that we needed to model real passengers. Unfortunately, most transportation management games don't do this. They just have a concept of moving stuff from kind of where it is to kind of where it's supposed to go, but you're not actually moving real people or real cargo, etc. So what we do is we continuously generate hundreds of thousands of passenger blocks. Each block represents between 1 to 25 passengers as it stands right now, where the small cities will generate small blocks of passengers, the large cities represent large blocks of passengers. So what we end up having is the equivalent of millions of passengers in the game. And these are generated up to 60 days in advance, just like you and I book our travel. What makes it even more intriguing is not all of these passengers are alike. The industry recognizes 4 different types of passengers on air travel. Now, of course, the first is business travelers. That's about 40% of airline passengers. There's leisure passengers, those that are going on vacation, for example. There's those that are traveling for personal reasons, such as visiting friends and relatives. And then there's also institutional traffic, which is for government, a university, such as a state capital or a major college town, for example. Now, these different types of passengers travel at different times of the year. The graph at right is actually taken from one of our data files for over the course of the year, the likelihood that the different types are going to want to travel during that time. Now, are we traveling to visit relatives at Thanksgiving? Are we there to take summer vacation with the family? Or are we traveling for spring break from college? Now, all of these are modeled after the real-world travel patterns. The different types of passengers also tend to travel at different days and times during the course of the week. With 2 examples here, the business traveler tends to travel more on a Monday morning and return on a Friday evening, or on the other hand, a leisure passenger is more likely to depart on a Friday evening or Saturday morning and return on a Sunday evening. And again, these graphs are actually taken from the data files that we use to generate passengers in the game. Well, so far we've been emphasizing the fact that not all passengers are alike. And so far we have facts that our passengers have an origin, a destination in mind, the travel day, which is generated up to 60 days in advance. For example, one passenger may want to travel early next week, another one might not want to travel for 6 weeks. They have a desired departure time, that is when they want to travel based on the information that we saw a moment ago. But they also have 6 preference ratings. Each of these 6 different passenger preferences is given a score from 0 to 3 that rates how important each preference is to that passenger. And these are really nothing different than what you and I use to book our flights and decide what's important to us. And they include things such as the cost of the trip, the comfort of the trip, for things such as the seat width and size, the entertainment available, the food and drink service available. The length of the trip. Is it a short trip, or are we taking a long time to get to where we want to go? The difference from the desired travel time. If I want to travel at 10 in the morning and there's a flight at 9, that's not so much of a problem. On the other hand, if the only flight available to me was at 4 in the afternoon, that wouldn't be as preferable as the flight that's closer to when I want to travel. The on-time percentage of the selected flight. If I'm a business traveler, I'm concerned about not missing my connecting flights. This may be very important to me. And an airline loyalty takes into account such things as frequent flyer programs. Do I want to fly the airline that I'm used to flying, for example? So now, definitely, not all of our passengers are alike. Those different preferences give us over 1,200 types of passengers, and certainly you can't please everyone. So when setting up your airline, you really need to make a decision as to who do you want to cater to, specifically business travelers, leisure travelers that would like low cost, or are you going to try to cater to multiple types? With all of these different preferences in place, we also needed to model some very realistic decision criteria to go along with them. Again, using 2 different examples from the actual game data. If the trip was a short one, the passenger would be very satisfied. But as the selected itinerary grows longer and longer, the passenger may very well be less satisfied with the trip, especially if it's something that's important to that passenger. As for the price of the trip, if it costs about what it's supposed to, the passenger is moderately satisfied. If it costs less than that, his satisfaction increases greatly. On the other hand, if as the cost of the trip increases, his satisfaction would decrease rapidly. So when booking itineraries, the first thing a passenger does is find available flights. It searches only the possible connecting flights on this itinerary, and it searches only flights with available seats. And then it goes through the process of rating each flight and each itinerary with their 6 suitability ratings, such as the graphs you just saw, and it applies each of the 6 preferences for that passenger to the corresponding suitability rating. So in the end, all the passenger is doing is what you and I do every time we go to book our travel. They're saying to themselves, of all of the hundreds of available itineraries from my origin to my destination on the day I want to travel, select the most suitable flights for me given my preferences. And all of this is continuously happening for hundreds of thousands of passengers every minute in the game.